Assalamu alaikum students. Today we are going to start chapter number 4 of D3. This is indices and standard forms. Let's start from the objectives first. Objective of today's videos are: what are the laws of indices? What is meant by index? What are indices? And what are the laws of indices and how we calculate these different laws? So let's start from the background. Why we have established these laws? Students, when we are going to study very large or very small objects, for example, with the passage of time, with the advancement of technology, mathematicians and scientists, they accounted for a problem. The problem was very huge and very small numbers. For example, the distance from Earth to the Sun in millions of kilometers. This was a very huge distance. So they accounted for the problem that there were couple of zeros or the values 2, 3, 4, 5 or very huge number. They accounted for a very huge number. So it was very difficult to write down this huge value again and again. If we want to add or subtract very huge value, then it was a problem. Contrary to this issue, for example, if we are going to deal with a microorganism, for example, the size of a paramecium, for example, the diameter of the bacteria, or the size of a small bacteria, or size of a DNA, so that also made a problem for the scientists and biologists. So very small value like 0.00000 and so on, or very huge value, that created a problem for the scientists. So they established a principle which can deal with this type of problem. That is a background of indices and the index notation. So let's start. What is index notation is all about? Why we call it index notation? For example, I write 5 into 5 into 5. This is a consecutive multiplication. For example, we have a number 5 multiplied by 5 multiplied by 5. It means that 5 is going to roll thrice. Scientists said that instead of writing in this way, why not to write 5 to the power 3? Over here, if we further dissect this value, we came to know that this 5 is called as the base, while this power function is called as index. It shows that 5 is going to multiply the index times, or in a simple way, base is going to multiply index times. Index is singular and its plural is indices. Indices is its plural and index is its singular. So this is called as the index notation. If I write down 5 into 5 into 5 in index notation form, so I'll write down as 5 to the power 3. Let's start from the law number 1. First law of indices says that a to the power m multiplied by a to the power n is equal to a to the power m plus n. What does it mean? What is all about a and m and n? Well, a, m, n are any numbers, or specifically I say that a over here and a over here as well as a over here, these are any real numbers. And you know, real number set is the biggest set in the mathematics. So a is any real number Okay, that could also be a digit, that could also be positive or negative. As you know, a real number set is the biggest number. So a is any real number, while m and n both are positive integers. At the moment we are dealing with only positive integers. That's why we will have just 5 laws in this video, because we are dealing with positive integers. Afterwards we will deal with the zero indices, and onwards we will also see that, for example, if it is not a positive integer, what if there is a negative sign here, there is a negative integers or negative indices. So dealing with zero indices, negative indices, and let's say if there is a transcendental function here, or if there is a fraction over here at this indices stage, so what will happen? So these are different laws. So first we are just going to focus on what if a is a real number and m and n are both positive integers. So just let me give you an idea what are the positive integers are. Positive integers, set of positive integer is denoted by z positive. It starts by, although 0 is also included in the set of integers. 0 is considered to be integer, but you know that 0 is neither positive nor negative. So we cannot say that it is positive 0 or negative 0. You know it very well. But you cannot exclude it from the set of integers. So in short, 0 is a integer, but it is neither positive nor negative. So I'll start by plus 1, plus 2, plus 3, plus 4 till infinity. So set of positive integers deals with 1, 2, 3 till infinity. Now back to the law again. This law says a to the power m multiplied by a to the power n is equal to a to the power m plus n. It means that if both the bases are same but their powers are different and bases are going to multiply each other, then their powers are added. These laws are used in algebra, and these laws basically deal with the indices. More like these are more related to the indices than the bases. Let's quote an example, then the situation will be more clear to you. For example, I have a number. For example, I write x to the power 7 multiply by x to the power 3. Here you can see x to the power 7 is going to multiply by x to the power 3. When both the bases are same but the powers are different and bases are going to multiply each other, so what would be the resultant? X to the power 7 plus 3, or I may write down as x to the power 10. This is the first law, which is very simple. I would like to repeat once again. If bases are same but the powers are different and bases are going to multiply each other, so their powers are added. Right? Now let's move to the law number 2. I'll just do minor changes in law number 1 and it will automatically be converted to law number 2. See, law number 2 says if we are having two real numbers which is denoted by a and they are going to divided by each other, like a to the power m is going to be divided by a to the power n, fine, then the powers are going to be subtracted. See, the law number 1 has been converted to law number 2. Very simple. Let's see. A to the power m is going to be divided by a to the power n. When both the bases are same but their powers are different or their indices are different, we call them indices, or power is one and the same thing. Their powers are subtracted. This is the law. For example, I take the same example. X to the power 7 is going to be divided by x to the power 3. It will be x to the power 7 minus 3. So what it would be? X to the power 4. This is second law. So from this discussion up to this point, we have concluded two things. Law number 1 says if bases are same and they are going to multiply, their powers are added. If bases are same but their powers are different and they are going to be divided by each other, their powers are subtracted. So I write down here for further references that law number 1 says AM multiplied by AN is equal to AM plus N, and law 2 says AM divided by AN is equal to AM minus N. Clear? Law number 3 says A to the power M to the power N. What does it mean? That for example, if A is having a power already and M is again, and the whole number is again having a power, so there is a power in a power. So this law says, for example, if there is a power in a power, so what happens? A to the power M to the whole power N, so the powers are going to multiply each other. And again, A is any real number. This A is any real number, while M and N, they both are the positive integers. Got my point? A to the power M to the power N. So there is a power in a power. So if there is a power in a power, these are going to multiply. For example, I got an example. I would like to take a simple one. X to the power 7 whole power 3. X to the power 7 whole power 3. So there is a power in a power. What it would be? X to the power 7 into 3. Powers are going to be multiplied each other. So it would be x to the power 21. Right? A to the power m whole power n. They are going to multiply each other. So powers are going to multiply. Next, we have law number 4. Law number 4 says, let's say if we are having a to the power n multiplied by b to the power n. What does it mean? Before law number 4, we were having a situation in which bases were same but the powers were different. For a reference point of view, you can see here law number 1 says a to the power m into a to the power n means both bases are same but the powers are different. In law number 2, bases are same, powers are different. And in law number 3, if there is a power in a power. But here the scene is different. In law number 4, if bases are different but the powers are same, a to the power n multiplied by b to the power n. So what we will do? We can combine a into b whole power n. You can say that individuals can be written as a composite form, or they can written as in a combined format. Their bases can be combined. So if a is going if a is having power n and b is also having power n, bases are different, powers are same. So bases can be written in a combined format. For example, let's say if I write x to the power 7 multiplied by y to the power 7. You can see both the bases are different but their powers are same. So I can combine them as x into y, both having the power 7, right? So for a reference point of view, write law number 4 here, which says that if I am having a to the power n multiplied by b to the power n, so it can be written as a into b whole power n. We can combine their bases. Let's move to the law number 5. Law number 5 says, let's say if a to the power m is going to be divided by b to the power m. So we can write down as a over b whole power m. So we can write down as a over b whole power m. For example, x to the power 7 is going to be divided by x to the power, y to the power 7. X to the power 7 is going to be divided by y to the power 7. So I can write down as x over y whole power 7. X over y whole power 7. Bases are different, power is same. So this law number 5 tells us that if we are having a to the power m is going to be divided by b to the power m, it will be a over b whole power m. So here are the 5 laws, in which first 2 laws are exclusively deals when the bases are same, and law number 4 and law number 5 deals when the indices are same. Okay, and law number 3 deals when there is a index over an index. There is a power of a power, or you can write down as power of a power, power of a power. So these were the 5 laws of indices. I hope this video will definitely help you to solve different questions of this chapter. In my next video, we will start exercise 4a, which is the first exercise of this chapter, and we will see how these laws are applied. Thanks for watching.